Hello, ladies and gentlemen. I'm glad to be able to talk to you tonight. I was asked to do a video on how to map out some of the trig functions like sine and cosine, how to shift them around, what each part of the equation stands for. So here's a nice video, hopefully it's nice, on how to do that. Let's start with the parent function, y equals the sine of x. All right, then we'll talk about what the different parts of the function are, and then we'll go from there. So the parent function is simply y equals the sine of x. It has an amplitude of 1, so it's going up off the center line 1 unit and also 1 unit down below the center line. I like to start mapping it out just by writing 2 pi, just out here. If you cut 2 pi in half, you get 1 pi. And of course, if you cut 1 pi in half, you get pi halves. And let's count by pi halves really quickly. 1 pi half, 2 pi halves, which reduces to pi, 3 pi halves, and 4 pi halves, which reduces to 2 pi. Now, the nice thing about a sine is it's going to come up and hit a maximum. First of all, it starts at the origin. It's going to come up and hit a maximum of pi halves, come right down through pi, hit a minimum of 3 pi halves, and come up and hit 2 pi. And then, of course, it's going to continue squiggling up and down forever after. Now, what if you have an equation like this, a little more complex? Here you have an amplitude of 3, and again, we'll talk about the different parts. You have 2 waves in 2 pi radians. We'll talk about that. We have a horizontal shift of pi halves, and we have a vertical shift of 1. So let's quickly go through what those parts are. So here is your general function, y equals a times the sine of b times the quantity x minus h plus k. Here are the different parts. A is your amplitude. That's how far it goes off your center line, upward or downward. B is the number of waves it goes in 2 pi radians. So if you have a b value of 2, it's going to go through 2 waves in 2 pi radians. If it were 3, it would go through 3 waves in 2 pi radians, and so on and so forth. All right, h is your horizontal shift, k is your vertical shift. Now, one thing that I want to also mention is that your period is known as 2 pi over b. So the actual period is known as 2 pi over b because the natural period of the sine wave is 2 pi. And if you have b being the number of waves it goes through in 2 pi radians, it makes sense that you would divide 2 pi up into however many pieces it takes to get your period. All right, let's go ahead and tackle this one. So as you can see, I've got a blank graph here. Now, notice that my amplitude is 3. I've sketched a center line. If you can see that, my black marker is getting a little bit tired. I've sketched a center line that's 1 unit up. So your parent function would shift from the x-axis up to the 1 unit mark. I can see that it goes 3 units off of the center line. So from 1 plus 3 is 4. 1 minus 3 is negative 2. Continuing on, I see that it shifted pi halves units forward. Remember, it's always the opposite of what you see in parentheses. So this has a shift of pi halves units forward. So to accommodate that, so I've got my center line here, but I'm also going to do an imaginary y-axis at pi halves. Just going to shift the whole thing pi halves units forward. And I'm going to label that. So this is what would have been 0. All right, let's go ahead and count by pi halves. Maybe I'll extend everything just a little bit. So we have 1 pi halves, 2 pi halves, 3 pi halves, 4 pi halves, and let's go all the way out to 5 pi halves, just to get another pi halves in there. We'll get 2 complete cycles on our graph. Since it's going through extra cycle. It's going through 2 cycles when it would normally go through 1. Let's go ahead and get some pi-fourths onto our graph as well. So you can start at 1 pi-fourths just to help you count. And let's write that in blue. I'm sure you'll be able to see it better. So 1 pi-fourths, 2 pi-fourths, which is pi-halves, 3 pi-fourths, 4 pi-fourths, which is pi, 5 pi-fourths, 6 pi-fourths, which is 3 pi-halves, 7 pi-fourths, 8 pi-fourths, also known as 2 pi, and 9 pi-fourths. And that should give us a pretty good map. So let's go ahead and just start at what would be the origin, and then we can continue on in both directions as desired. Now, going through 2 cycles in 2 pi radians, we know that this is going to do pretty much what the parent function did, only twice as fast. So it's going to start at our imaginary origin, going to hit a maximum at 3 pi-fourths. It's going to come right down through pi, but keep in mind it's going to hit pi at our center line, not on the x-axis. So I'm just going to bring that right through here. It's going to hit a minimum of 5 pi-fourths. Going to come right up through our center line at 3 pi-halves, hit a maximum at 7 pi-halves, come right down through our center line at 2 pi, hit a minimum at 9 pi-fourths, and we're back to our center line at 5 pi-halves. Not the best drawing, but I'm trying. I'm not going for perfection, just trying to help you guys out. All right, and let's continue on a little bit more in the other direction. So I know that I'm going to hit a minimum at pi-fourths, but again, not the pi-fourths here, the pi-fourths on my center line. So right about there, and then it would come up and hit the origin right about there. All right. Okay, that should do it. Just a quick review of what we just did. This equation was shifted pi-halves forward, always the opposite of what you see in the parentheses, 1 unit upward. So what would have been our origin shifted pi-halves forward and 1 unit upward. All right, our amplitude was 3, meaning that it goes 3 units up off the x-axis, or what would be the x-axis, and 3 units down below. I'll call it the center line, that's better. I hope that helps you out. Once again, I really appreciate all of the hard work you guys have done. I appreciate each and every one of you. Good luck. If you have any other questions, please ask. I really appreciate the question, and I appreciate being able to do these videos for you. Thanks a lot, guys.